Hello everybody, this is Sky Darmus with some new results. Last year I calculated the perihelion precession of Mercury and I exceeded Einstein's precision there. As I explained in that video, Einstein's theory does no longer agree with the perihelion precession of Mercury since 2017, when the perihelion precession coming from all the different planets was calculated with more precision, including all the objects in the solar system. And when you get too much precession, there's not much you can do to reduce that in Newtonian gravity or in Einsteinian gravity. But in my theory, where the perihelion precession and gravity in general is composition dependent, there you have actually a little bit less perihelion precession because the planets are generally heavier. In the mainstream, they're basically treated like iron balls because the G value that the mainstream is using was measured using iron, and so it's much higher than the G value of other elements. And planets are very far from consisting mainly of iron. So when I did this calculation the last time, I used the normal semi-major axis of the planets, which are basically their distance from the sun. But it turns out that when we use non-Newtonian gravity, like we do in SPD-quantum gravity, the Kepler ratios are different for every planet. And so when we use the correct semi-major axis of the planets, then we get slightly different perihelion precession. So for Mercury, we get this number here, and the agreement is now very phenomenal, much better than last year actually, because last year I was referencing a value measured in 1947 by, who was it? Well, you can check in that other video. But now these two more modern values here by Duncombe and Anderson, they're like this, and my theory agrees to 99.97%, whereas Einstein's theory only agrees to 99.89%, and I actually have agreement within margins of error, and Einstein doesn't have that. So we can say it's actually 100% agreement. And in this second case, the standard deviations are much smaller. So here there is no agreement within margins of error. But if we just widen them a tiny little bit, then we get agreement within margins of error for my theory, not for Einstein's theory. Okay, that's all for now. And well, there will be very soon there will be an interview of me and Robert Sheldrick's already been done, just not uploaded yet. It was the interview took place yesterday. Okay, that's all. See you.